All right, hello and welcome. Today we are diving into something, well, it's truly fascinating. It's a concept that connects this classic, beautiful piece of literature with some of the most advanced AI out there. So, get ready. We're calling this one Data Alchemy, the glass bead game. We're going to see if it's actually possible to turn raw, messy information into pure golden insight. Okay, so our whole journey today really starts with this powerful idea from the Nobel laureate Hermann Hesse. In his novel, which came out way back in 1946, he dreamt up this incredible game. Think of it as this grand synthesis of all human knowledge. He called it a universal language, a way for players to connect totally different ideas, to create a real dialogue between things like art and science and philosophy. So what was this game exactly? Well, imagine this. Imagine you could take a theme from a piece by Bach, right? A beautiful musical fugue, and then connect it to a complex mathematical theorem. And then, just for good measure, relate that to a line from the Upanishads. And you could do all of this inside the rules of one single elegant system. That was the dream of the glass bead game. It was a way to see all those hidden threads, the ones that weave our entire culture together. Now, in the book, this game didn't just pop into existence, right? It evolved. It had this whole history. It actually started out pretty humbly, back in the early 20th century, as just a simple memory exercise for music students, using colored beads to represent musical ideas. But then, about a decade later, mathematicians got a hold of it. They saw the potential and started using it to explore logic and patterns. And from there, it just grew. Over centuries, it absorbed every field of study until it became this universal medium, a way to literally play with the very structure of knowledge itself. How cool is that? And that brings us right to the heart of what we're talking about today. I mean, Hesse's vision was amazing, but it was fiction, right? A kind of utopian dream. But now, with the incredible power of modern AI, you have to wonder, could we actually build something like this? Could we create a game that genuinely connects all these different fields of knowledge for real?
Okay, to even begin to answer that question, we've got to look inside the AI itself. See, when we train these huge language models, they're not just memorizing text. That's not what's happening. They're actually creating these vast, incredibly complex internal maps of information. Researchers have a name for this. They call them latent spaces. And you can think of a latent space as a kind of hidden, invisible universe where all the ideas and concepts and words are organized based on what they mean.
And this is where we hit this central problem, the big challenge. On one hand, the promise is just huge. These latent spaces contain vast knowledge, they can find patterns we'd never see, and connect ideas in totally new ways. But there's a flip side. The problem is they're so complex we can't really see inside them. They're what we call high-dimensional. Plus, the models change so fast, what you discover today might be obsolete next week. And maybe the biggest problem of all, it's really hard to keep us humans engaged in exploring a world that's so abstract and, well, invisible.
So, here's the bottom line. We've got this entire universe of interconnected knowledge, basically locked away inside the AI, but we don't really have the right tools to go in and explore it. It's like we know there's a new continent out there, but we don't have a map or a compass. And more than that, we need a compelling reason to even make the trip. So the question becomes, how do we turn this abstract, invisible space of data into an actual playground? A place where we can go and make real discoveries.
And that is exactly where the solution proposed by the researchers behind all this comes in. They came up with this brilliant method for taking those abstract, invisible data points and turning them into real, tangible, playable game pieces. And in a nod to Hesse's novel, they call them motif beads. They have this perfect metaphor for the whole process, too. They call it data alchemy. And it's so fitting, right? Just like the old alchemists wanted to turn lead into gold, this process is all about turning raw, messy digital information, like a bunch of text, into something structured and valuable, something like a deck of playable cards. It's literally about finding the hidden gold inside the data. Okay, so how does this data alchemy actually work? Well, it boils down to 4 main steps. It's like a recipe. First, you start with your raw data. Step 2, you use AI to create something called a vector embedding. Step 3, you pick a symbolic system. This is going to act like your map or your lens. And finally, step 4, you use a little bit of math to glue everything together. So let's walk through each one of these. All right, step 1, start with some raw data. And for this project, the researchers chose an absolutely incredible source. It's called the Thomson Motif Index. And what it is, it's this massive catalog of over 46,000, get this, narrative motifs. These are the fundamental building blocks of stories collected from folktales all around the world. So you'll get an entry like H1594.1, foot race between fairy and mortal. Every single one is a core story idea. Okay, now for step 2. This is the AI part. This is where the real magic happens. An AI model goes through and reads the text for every single one of those 46,000 motifs. And for each one, it spits out a long list of numbers. That's called a vector. Now, the best way to think about this vector is as a set of coordinates, like a location on a map. These coordinates place that motif at a very specific point inside that huge invisible latent space we talked about earlier. And here's the cool part. In this semantic space, motifs that have similar meanings naturally end up closer to each other.
Step 3 is where it gets really clever. You have to choose a symbolic system, and this step is absolutely crucial. See, right now, you've just got 46,000 points floating around in this abstract space. To make any sense of it, you need some kind of structure, a scaffold to hang it all on. For this experiment, the researchers chose something familiar, the 56 minor arcana cards from a tarot deck. And then they did the same thing. They took each card, like the 7 of Swords, and ran it through the exact same AI model to get its coordinates in that very same space.
And that brings us to the final step, step 4, gluing them together. So now, think about it. Every single folklore motif has a location in this space, and every single tarot card has a location in the same space. So now you can do something that's actually pretty simple but incredibly powerful. For every one of those 46,000 motifs, you just calculate which of the 56 tarot cards it's closest to. That's it. The fancy math term is minimum cosine distance, but really, all you're doing is finding its nearest neighbor.